Okay, so software engineering course the last week before the spring break. So we are now doing these direct video lectures because we had a vote last week and decided that we don't actually necessarily need to have these Monday morning lecture events. Of course, a bit funnily enough, I'm actually giving this speech or making this recording at the same time I would be giving the lecture, but this week is a bit of an exception because I didn't have time to do this lecture recording before this Monday morning. Anyway, uh, we have a lot of things to cover here, so I'm going to keep this brief. And so let's get started and see what's what. So, software maintenance course, week 7, and this week we are covering yet again 2 new additional things. On this week we are talking about software production lines and expanding discussions over software version control, which both of course are not new topics or new aspects, but they are things of software maintenance which are regularly mentioned as important things or important aspects of doing software maintenance and software quality work. On the exercises, we are also doing something with GitHub and talking about production lines. So this week we are more or less covering the aspects of version control and expanding that on the idea that there's a large companies which might do some things a bit differently. Of course, we have a huge set of slides again, so let's get to the business and see what we actually have to cover this week. Like always, let's take a quick recap on what happened last week. So we were talking about reverse engineering. So in a case we lose important aspects or try to salvage something from our materials when something catastrophic loss of information has happened, or we have to adapt into a legacy system, or more realistically, we have to make small change to some legacy system which still needs to be serviced or catered by our software so that it still works. The general concept of reverse engineering, of course, is that unlike normal engineering, which in this context is called forward engineering, the reverse engineering goes backwards in the idea of normal waterfall-based approach on software engineering. So instead of doing gathering requirements, doing analysis work, designing an architecture, and implementing what we designed, the idea is that we actually go to the reverse flow of things. So from behavior, try to salvage source code, or from behavior, try to understand requirements, or from the structure, try to understand what sort of things the system has or what sort of modules the system has. Of course, these all are things that require us to understand what the legacy system was or try to recreate the things so that we can at least partially salvage the things that already exist or understand what the system was doing so that we can, for example, use the old hardware systems without having access to the documentation or original materials describing how the system behaves. So the requirements engineering has number of the software re-engineering was the other topic we were talking about on the course slides. Of course, this meant that we would be reorganizing and modifying the existing software systems to make them more maintainable. This, of course, overlaps with the reverse engineering, meaning that if we have a legacy system, we sometimes might want to do re-engineering work to make the system maintainable, or make it cheaper to maintain the software, or simply make the software usable directly on new hardware platform. This of course means that for some reason we can migrate to or we can't use virtualization or some other simulated environment, but we have to migrate to new technology and new foundation with our software. The example I used on the lecture was that, for example, the industry automation systems more or less require the same sort of similar static hardware. So the system might need to be re-engineered every now and then to be usable on modern hardware platforms in cases where we can't use or keep using the existing older hardware platforms, or the hardware platforms are no longer manufactured. In any case, the re-engineering was an aspect which could be considered if we have still access to the original source code and the tools and the migration tool, especially the migration tools to handle all the work, because otherwise it would be laborious and there's only a number of cases where these activities would be cost effective or even reasonable to do without these specified tools. So, based on this, we get to this week's topic, the software product lines and software configuration management. Like mentioned on the introduction, these both things are more or less about version control things which affect how we should maintain or how should we build our software. So can we replicate things, or how can we migrate ideas from somewhere else, like automotive industry, into software development to make mass tailorable product which we can sell to several different places without actually having to redo the entire software each time we are trying to do something new. So let's start with the terminology to understand the differences or the subtle differences between all these different things. First of all, the software product management. It's the discipline of building, implementing, and managing software or digital product, taking into account life cycle considerations and an audience. So software product management is more or less the normal way of doing software. We gather requirements, we try to understand our audience, our customers, people using our software, and we make them something that they consider worthwhile or usable or somehow a thing that they would be ready to invest their money or time into using the software. When the software gets older or the life cycle moves onwards, there will be a maintenance issues, but as long as we have something feasible, we keep extending the lifetime of the product by doing normal maintenance cycles. So basically, the normal way of doing things. We find a market, we find a customer, we make a product, sell the product, and finally, when we are done with the product, we kill the product. Or we make the sequel of the game or the movie or whatever. But still, the software product management is more or less the general term talking about the normal life cycle of a software product. So, the software configuration management. It's about the systems engineering. It's establishing and maintaining consistency of product's quality attributes. Meaning that the software configuration management itself is something that we do to see and oversee and manage the different aspects of the software. So ensuring that we have the most stable or functional working builds, in fact actually stable build or experimental build or long-term support builds and these sort of things are actually aspects of software configuration management, because they are more or less baselines or quality lines or quality control aspects, ensuring that we actually have something that's, for example, deliverable to customers. Or if we are experimenting with new technology, we have a separate branch of the software we are developing further, and the other branch which we are offering to those customers who have opted out from using unstable and experimental versions. So basically, it's tracking and controlling the changes of the software, including revision control, establishing baselines, establishing long-term support versions, and all these other things. And of course, it's not only that. It's also about determining what has changed, who has changed things, what needs to be done on, for example, the next revision, or what things we still have as a problem. And finally, if we come up with a problem, the new version is awful, we need to roll back on something, we can do it as managed activity and just skip a version or throw out a branch that didn't go anywhere, and we can determine what needs to be done. Also, well, if we have a functioning system, we have several modules, of course, and we can also manage the internal hierarchy or architecture of these things. We know what modules we need to revise, for example, for platform migration or going to a new software platform. But these are more or less things that we actually that are in joint venture with the other aspects such as software architecture. But anyway, we can also manage, for example, different release servers or different with the software configuration management, because we can track and identify the parts that are usable or functional, or at least the ones we need to use if we want to deliver something to our customer. Finally, the software product lines are the concept or idea of using software engineering methods, tools, and techniques in a similar way than, for example, the automotive industry or the airliner industry works. So we create set of assets, components, parts, partial products, which can be combined or, if necessary, tailored to suit different users or customers by means of sharing these modules between several similar products. It means that if we want to, for example, sell our warehouse management software to one retail chain and then want to sell it to another place, we have product line product which sells warehouse management software, but we can tailor the necessary parts to fit to our new customer, and we also at the same time have the product which was already sold to the old customer. Or if we want to go from warehouse management to something like hotel room management, we can try to use the assets which we already have, for example, like database management stuff and these sort of things, in our new product, because we only have to create the parts which we no longer have. In general, why this exists? Well, it's not always worthwhile to write everything again. If we have some components which still are relevant or can function on a modern technical platform, for example, some Java code which runs just fine on the runtime environment. Of course, using Java itself is another issue, but let's not focus too much on that. We are in a situation where software, especially if it's used somewhere non-cutting edge, like warehouse management or insurance policy management or bank management or whatever, what place which sort of expects stable environment, these things can live for something like 30 years. So it's not a completely ridiculous idea that these products have the same life cycle than most people's professional careers, for example. So we need, of course, new customers, we need new users, or at least after 15 years of use, we sort of can expect that this part actually works. That's what it's expected to do. So why not replicate and recycle or reuse that part in some other software project or process which does something similar, because we already have done that, and it would be a complete waste of time to redo the thing again. So basically, what the Carnegie Mellon Software Engineering Institute says here, a set of software-intensive systems that share a common managed set of features satisfying the scope, specific needs of a particular market segment or mission, and that are developed from a common set of core assets in a prescribed way. It's quite easy to see that this simplification was designed by a lawyer, at least on my occasion. But anyway, let's not focus too much on that. So basically, what it means is that if we consider the software product lines in the idea how it actually functions with the other terminologies here. Of course, the software product management was the, so to say, normal software engineering process. So it starts with the requirements analysis and sort of ends with the acceptance and operations. We made a product and then it's available online, and at some point it comes to the end of its natural life cycle. It's replaced by something else, or it's internally replaced by a newer version. Of course, the software configuration management then, on the other hand, means that we are extending the product over the baseline again and again and again. So we are doing maintenance work on the product until it comes to end of its life cycle and end of its support, and then it dies a natural death of the software. Finally, the software production lines, or the product lines, here are depicted as a box aiming towards the requirements analysis. This means, of course, that each time we launch a new product line, we more or less have a new market for it, or new customer, or new industry segment, or something like that. So we have to gather requirements specific to that area of interest, whether it's a market or audience or customer or whatever, and then try to come up with the things that we already have and tailor a product that suits those new people, the new requirements. So basically, it creates a completely new product based on existing things that we already had. That's why the product line refers to the requirements analysis, whereas the other things refer to the software lifecycle on its entirety, or only to from requirements analysis to acceptance and operations. So let's focus more specifically on the software configuration management first, because this is the more technical part of these two things. The product lines are more or less a concept which is fairly simple to understand. But the configuration management, okay, so we need to have some managed way to run or develop our system further, or identify the different versions of the software or the parts of the software from each other. So what do we need to do? First of all, of course, this is the main problem. Well, it's the main problem on this figure is that it's depicted with the clip art artists, but because this is a slide taken from the referenced slide sets, I didn't want to start fixing it too much. But the idea more or less here is that if we don't do this type of work where we try to do configuration management, we have a first product. There's a problem in it. The customer doesn't like it. So we fix the problem with the release 1.1 and everything works. Of course, there's a good chance that the fixes or changes of the 1.1 never actually find their way into the second version of the product, or the version 2.0. So the bugs are back and the customer is pretty pissed off because they are again struggling with the things that would have been or should have been fixed beforehand. Or they actually even were fixed beforehand, but the customer got new bad version of the software. So obviously this is something that needs to be done. So what do we need to do? Of course, the problem is that, like with most things I have mentioned beforehand, the software doesn't have inherent shape, size, requirements, or anything depicting how it should be actually constructed or even designed. There is no best practices of architecture in a sense that if you are making a building, it needs to stay upright, and if you are making a bridge, it's a fairly bad thing if it collapses. But with the software, if you manage to make it build and run, there's really it can be a complete hassle of things, or it can be something that's actually manageable. So if the software is uncontrolled and undirected, it's going to be a complete freaking nightmare to maintain the software. So that's why we also need to have some sort of rules or ways of ensuring that some parts are fenced to one area, some modules are done somewhere, and that we have identifiable chunks of source code, modules, objects, whatever you call them, which can be upgraded separately and maintained separately so that we always have something that works, no matter how horrible thing the original work was. So the configuration management is a software engineering discipline comprising the tools and the techniques that company uses to manage change in its software assets. So we have something which works with, it has customers, it's a legacy code repository or something like that, a product, and we have approaches, change needs, new requirements, stuff like that. So what tools do we use to manage the change from the old version to new version, and what sort of activities do we need to do to ensure that everything happens in a controlled environment? Of course, like always, this isn't something that really concerns a small game studio or some studio group which just keeps doing a small time software development, but it's actually more of a concern of a large company or organization which would need several hundred people to know the same things at the same time, or several studios to know the same things at the same time. So kind of things that happen in a controlled fashion. So basically, it's how you control the evolution of a software project. So each time you have to do something, or each time your developer has to commit something, or the testers are finding bugs and fixing something, you are making a change to your software product, and that's why you need to have software configuration tools and software configuration management. So the IEEE standardization says that it's something that needs to be done. Simple as that. So it's the minimum required contents of software configuration management plan are established and the specific activities to be addressed and the requirements for any portion of the software product life are defined in this standardized approach. So basically, it's something that you should always have, or you end up having anyway. Even if you think that you only want to do one release and then be done with it, like some shovelware games, for example, are done. Still, we are also talking about internal development and internal steps towards the actual software development. And this is actually interesting because the first standard version was released in '83, so it's roughly the same size, age than I am, meaning that this actually was a concern already when we were using smoke signals and frigging sticks to do the computing work almost 40 years ago. So software version control and the management constitutes a good engineering practice for all software projects, and of course it's not related to the actual development process approach. Even if we are using agile or a continuous delivery or whatever we have been talking about on this course beforehand, it's not really related to that. It's about the version control works and the version control tools and the ways of managing how we release new versions or roll out, for example, the new user interface, the tools which are required to do new versions of the software in a controlled fashion. Of course, it enhances reliability and quality. That's also why it exists. So the idea is that the management work or the software version control provides a structure for identifying and controlling documentation, code, interfaces, and databases to support all lifecycle phases. It supports development and maintenance methodologies and blah blah blah, all the other different things related to the ways we are doing our software regardless of what we are actually doing. So the configuration management is a sort of a discipline. It's not really something that can be defined, or that okay, it's this work, or it's this debugging work, or this unit testing work, or all these things. It's more or less about the practices and people doing work or documentation work, or the entire group participating in the documentation work, maintaining the integrity and traceability of the software and the configuration, which is the current best build or the experimental build or the long-term support build and these sort of things. Because, for example, on some occasions, the long-term support version might be several years behind the current experimental version of the software or the operating system. So, of course, we need to keep those things completely separate. Long-term support exists only because it's meant to be something that's not changing every now and then. So of course it's a completely separate entity. But on the other hand, we might want to gather experiences or performance reviews or stuff like that from the long-term support version, or recommendations, or what the users of that version of the software are doing, so that we might migrate the ideas into the newest version of the software, the experimental version of, or in any way the newest version. So this might actually mean that we end up using the old version or its ideas somehow in the newest version, and we have to merge different things or gather new requirements. And of course, this is something where the configuration management or the version control management comes into place. So according to SWEBOK, which by the way is the Software Engineering Book of Knowledge, basically functionally a Bible of our discipline, there's a huge number of things here. Actually, you also should understand that this webbook is actually completely free. And the 2004 version actually isn't even the most recent version of the webbook. So if you want to go through these things in detail, or actually even see more about how the American standardization organization sees the software engineering work, you should check out this webbook. It's surprisingly lightweight. It's surprisingly short and surprisingly clairvoyant in a sense that it doesn't end up being lost in a woods of minor details over minor details over minor details. This might look a bit confusing here, but for example, if we consider what is actually software configuration management, of course we need to identify the items. So what are the interfaces, outputs, or the data management systems? What are the actual activities we need to do? What are the ways of ensuring that these things are done? How do we audit our change trails and these sort of things? Of course, if we are making a mobile game, that's really not that important. But if we are making something that, for example, a patient's life depends on, it's a completely separate thing. And of course, how do we actually do it, and with what tools we actually do this work? So continuing, there's several other things which also identify how these things are done, or codify or document how software version control management should be done, or configuration management should be done. For example, the 12207 software lifecycle process model is one fairly interesting standard, because it's also IEC approved standard, so it's actually something that's probably also usable in this side of the pond. Also some measurement certifications like CMMI also taking into account these practices or try to audit how these things are done. So the more information about this is also available there. And of course, there's also a local national standardization like this NTC ISO, which is a translation to Spanish, for example. And there's also similar things done by FISMA in Finland, the Finnish Software Measurement Association. So, of course, if we want to manage the different configurations, we first need to have things to manage. We need the Lego blocks, which we select that these things will build our software when it's completed. In this case, they are called configuration items. And of course, the item can be any selected artifact or set related, a set of selected things that somehow are related to the software. And of course, these can be the code, source code itself, the executable objects, the scripts, the documents, the graphical assets, these sort of things, which are required to use one logical module of the product. It doesn't always have to be one library of source code or something like that. It can also be something a bit more complicated or a bit more abstract, like a level on one game or a set of levels on one game, and then you just select the ones which function or ones which work and include those on your build product and leave those which didn't work or the customers hated outside from your product. It can also be something small like sound effects and these sort of things. But in any case, all these things are configuration items. And the set of items is one product or the one version of the product which is given a version number and which is a one coherent set of things which always functions in a way that we already know that this version of the product was tested and the quality assurance said that it's good enough for launch or good enough for delivery. So this is the version we are using. This is how it has to be done because, of course, there's a huge wealth of different ways of doing things otherwise. So, like mentioned earlier, the software configuration is physical and functional features of the software exposed in a technical documentation or reached in a product, and set of controlled configuration items at the given moment of time. So basically, it's a compilation of Lego blocks, these all different assets combined together to form a product. This is more or less whatever all that it is, even though the technical jargon tries to make it look like something more fancier or interesting. We select the versions from the version control or from the asset database or whatever asset repository that these parts constitutes the current release version of the game. Do not change these, or if you change these, they form a new branch of product, which we might create new features or add more activities or add more content or do something else. But these items form a product, which is the version 1.1 or something like that. So these has to be preserved and maintained because this set is the one we delivered, and this is the exact same product that's already in use by our customers. So of course, with this mindset, we come with the versions and variants. Obviously, if we are only working with one hardware platform or one marketplace or one audience or one place, for example, doing a browser thing where you are using your service or product in a browser, there's not that many versions or variants. But of course, if we are doing maintenance work or delivering new features or adding content to our product, we end up with new versions of the product simply because we have to define a new release set of things. Okay, so this was 1.1, this is 1.2, this is 1.3, so on and so on and so on. Of course, if we are using different platforms, for something simple, like for example, uh, Google Android uh, and versus Apple's OS X uh, iPhone environments, we have to have the same product but on two different operating systems or two different places. So of course, the 1.1 version, which was released on Android, cannot be exactly the same thing as 1.1 version, which was released on Apple products. Of course, there's going to be some differences, whether it's in a modules made by us or modules made by the company or the organization or the product which made the linking and compilation work, or making the app of which is compatible with the hardware. But in any case, we need to have records, and we will have variants at some point of our software. So we have to also know how they different from each other. And of course, if we are looking for one bug which is in one variant of the software but not in the other, we already sort of know we should know at least what are the differences, so we can find the real root cause of the problem. And of course, this means that we are talking about the four main aspects or ideas or concepts of version control: branching, building, releasing, and the delta of things. So, of course, the build is the combination of components of a system in executable components in a target configuration. So that's more or less the thing we are delivering or distributing to our we could deliver to our customers. The release of the product is then the build wrapped around with the just the executable code and the necessary assets to run the software, and it includes installation files, the data, the settings, the release notes, and manuals, and these sort of things. So it's not only the thing we built, it's also the package which is required by the customer so that they can actually use the product. And finally, the concept of delta. Well, of course, it's the difference between the new version and the previous version. So if we know that something happens differently, then within the delta are the problems or the things that are causing the problems. And the branches, of course, are the branches of the version control. So we might have several variants going on at the same time, or experimental version and the stable version going on at the same time. And every now and then we merge these branches if we find something worthwhile to bring from the experimental versions to the main version of the software. Of course, there's other things. For example, the baseline version of the product. The baseline is actually nothing really fancy. Like always in software engineering, I've been saying that this is not a rocket science unless we are building rockets. But anyway, the baseline of the product is something that it's formally reviewed and approved, and it's basis for future development. And you can't really make changes to the baseline itself. It's something that we know that functions. It's a build that works. It's something that was distributed to our customer. It's something that fulfills all the requirements, at least to an adequate degree. So if we are doing something else, we can experiment based on our baseline version of the software. It's something that is of good enough quality that it can be used in the future as a starting point for further development. Also, the baselines from one baseline to another are also used to track the software configuration at the discrete point of time. So who is doing what and what is happening, and how well the system works. Of course, this also means that we, for example, based on this example here, if we have some, for example, the working proof of concept, that's a functional baseline. If we have something that we have a design for, or we know what we are building, that's an allocated baseline. And of course, when we have the first product, which is something that we can launch or sell or distribute, it's a product baseline. Of course, these things more or less rely on the thinking and ideology that we are doing things in this strictly controlled manner, where we are doing all the system design before we actually start implementing things. But the general gist is more or less that the baseline is of good enough design or high enough of quality that we can use it as a start point for all the further endeavors to try to enhance our product or make new versions of it, or make the proof of concept or prototype version to more mature state in pursuit of trying to achieve something that we can actually release and use as a commercial product or service. So of course, the rational unified process also defines things for baselines. It's that their idea is more or less that the baselines create or allow us to reproduce the problems caused by delta, the changes. We can trace things, where things started to go wrong, and we can report things, for example, how much changes or how much work or how many new features or how complete our new version of the software is based on the things that we need to have and based on what the things that we have already implemented on the baseline version, which was the starting point of this cycle of the development iteration. So of course, this means that this supports also the iterative development work, but also means that we can, as a management, observe how things are advancing in our product development. And of course, like I mentioned, the baselines work only if they are stable builds. So each iteration of the project, this means that, for example, with Scrum, when we have done everything, we have implemented all the new changes, and we have done the quality assurance work, and the quality control has signed a waiver saying that this work is now done. That's when you create the baseline of the product. So it's something that we can measure against, whether it's performance or security or how fun it is or how much content is it in there, or are these levels better than the previous ones. Whatever you want to measure, you can always measure it against the previous baseline. So is this product moving forward? And of course, if we found out that this new version of the product is in fact worse than we already had before, we can use the version control to roll back to the previous baseline and continue development work from that. And of course, this is the interesting part. Well, not really, but still, this also ties everything nicely into the continuous integration and continuous delivery mindset. If the iterations are short, the baselines, of course, are close to each other, so there's a small delta between them. So we know, or can almost even predict, if the changes are going towards right direction, or if we are advancing towards something that's favorable to us. For example, fulfilling our quality attribute requirements. So there's a couple of things that should be done in this to enable the best practices of the software configuration management. For example, identify and store artifacts in secure repository so that you don't actually have to end up relying on the reverse engineering tactics. Control and audit changes to artifacts. So if you are changing something that's fundamentally important part of your product, you might want to also consider that not everyone might agree that is this good or not. So you should have frozen modules or frozen versions of some modules of your development work. You should also use versioned components. So not only should you use versioned product, you should also have versioned components of inside your product, meaning that you can actually manage the different versions of the system. So when you are rolling out changes, you can do only partial rewrites or partial re-engineering by switching at once to using some newer version of the product which we know that works and is tested, and the quality control says that it's okay to use it. Of course, create baselines every now and then, especially at the project milestones, and record and track requests for change. So basically collect tickets, see who is doing what the customers are asking, and so on and so on and so on. So these are the more or less the best things you can do if you want to do the configuration management work. Also, something like organize and integrate consistent set of versions using activities, maintain stable and consistent workspaces, and so on and so on. Integrate early, do, for example, the continuous integration approach so that you don't have too much things to do at once or at the one branch merge activity, because otherwise it might descend into complete chaos because there's too many differences between the branches, and it's starting to look like that it's actually two different products. But of course, we have been talking about these things beforehand, but now these things are also starting to pay dividends in a sense that, for example, if we don't follow the ideas or the best practices, then we might have problems, for example, doing the configuration management or version control of the software. And finally, of course, even though we are trying to bring order into chaos, and bring versions, bring baselines, bring controlled builds into our software, the reality of the life is this. The systems almost always are really, really, really complicated things. So obviously, it shouldn't be necessary to emphasize that the version control systems and the ticket-based control management, who is doing what. And for example, now we are upgrading in this iteration this subsystem and focusing on these parts, and we do not touch these components or this subsystem. Then these parts should be self-explanatory, because these software products and services tend to be huge. So of course we also should consider that we might want to always manage them partially, because otherwise it will just descend into chaos. So basically, we have also some tools to do help with this work. They usually automate and facilitate the application of the best practices. And realistically, if you are trying to run configuration management out of a group shared Dropbox folder or something like that, you are already a complete maniac and should probably seek help with that. But anyway, the idea is that you should always try to rely on your architecture to help your maintenance work. This is something that I've been trying to emphasize on this entire course, that there are tools which help you, and there's no reason or only excuses to avoid using them. So, for example, what things are configuration management tools? Git, Mantis, Bugzilla, Subversion, IBM, stuff like that. So basically these things already help you, so you should probably also try to use them to your advantage. If you are doing something when web collaborative, you are working long distance, or you have participants from other places, or you are an open source developer, there's places where you can do web collaboration, and these things help you with that. In general, the basic functions of these tools are more or less to maintain a library or repository of files, to create and store multiple versions of the files so that you can actually have different builds and variants and these sort of things. They also provide a mechanism for locking or enforcing serialized changes to the files or sets of files so that you can roll in or roll out the different versions of the software, and also do help you with the identifying the versions and what are the sets required to build and extract or retrieve any version of the software of the file which was at some point in the repository. Of course, there's some limitations on that, but in general, it should allow you to roll back even to the first version of the first prototype of the first thing that you were doing. So basically, it's these sort of things. So you do checking commits or something else. It doesn't really matter. You can do things with group or with someone else. And actually, if you are going to a larger project, there's some other concerns. For example, uh, if you are working in a larger project, it might actually be worthwhile to understand that the tool itself only ensures that you have a possibility to do things. If you have several groups of users, there's still a possibility for people to do bad work. It doesn't go anywhere. But for example, as mentioned here, you should understand that the tools themselves don't solve all these problems. You also have to have someone who is managing the work or overseeing the work or overseeing that the things are done as they should be done. This is something that's similar, for example, to reviewing the source code and seeing that everyone is using the coding conventions or the documentation of the commenting conventions, these sort of things, simply to ensure that everything is happened in a predictable way. There's actually even idea of the unified change management part of the rational unified process. And for example, here there's a completely separate person who is responsible for overseeing the configuration management work. The idea is that of course, this is from IBM's own materials, so this might not be available to you or even me at this point to a very large degree, but these things are explained in this rationally unified process, for example, in this unified change management manual. There is several roles and activities defined in the approach, and the interesting part is that the configuration manager is a completely separate role. If we are running a huge project, something that applies, for example, to follow the sun principles and stuff like that, there is actually someone whose role is to oversee that the configuration is actually done and there's the version control is applied correctly and there's actually a sensible way of doing these things. Of course, whether this is the person's only role or if they are just some bureaucrat who is only spinning their pencil on their table, well, that's really up to you to decide. But still, this software configuration and the management of the work is considered important enough that it's actually a completely separate work. And of course, I tend to agree with this because each time we have more than 5 people doing some work, we might have problem because simply it's impossible that everyone at the all times knows what each of us is doing. So that's why we also need tools and conventions on drive and manage this development work. And for example here, what the software architect is doing is that they are taking all the models and making a actual functioning system out of it. But for example, what the configuration manager is doing, they are overseeing the different plans and the different components of the software from the project repository and making decisions on what parts are used in each deployment or what parts constitute, for example, one version of the software or are bundled in to the build to make it a released version of the software. And finally, well, there's some other things. So software configuration management and software configuration management activities, software configuration management schedule, and software configuration management resources more or less define who, how, when, and what is done when we are trying to implement these things or doing the configuration management work in a software project. So if you want to have more information on this aspect, get that standard. It should be available online. Just use Google Scholar to find it, and you can read more about this formal definition of the configuration management work. So that brings us to the second part of the lecture, the software product lines. Of course, like I mentioned earlier, the software configuration management is something that's a bit of a more technical work. It's something that's done with the tools, and it's something that's done to ensure that we have something that's always deliverable to customers. So what is software product lines? It's a bit of a similar sounding thing, but it's actually more of a concept of how doing controlled reuse of software. So, in simple, software product line is a set of software-intensive systems sharing a common managed set of features that satisfy the specific needs of a particular market segment or mission, and that are developed from a common set of core assets in a prescribed way. Yet again, someone hired a lawyer to do this. But anyway, the software product line, like mentioned, is the idea that we have assets in our programs. We have the core assets, which define or manage how the system functions, and we have some auxiliary or artistic assets or other things which more or less define the content of way to use the software or something to that degree. So by combining these assets in different ways, we can create software that hits different market segments, different tasks, different abilities, or create different products. For example, like the from the old original Nintendo Entertainment System, the 100 million different Mega Man games or Rockman games if you are from the Asia. But anyway, they more or less all are based on one core system, which, for example, could be the game engine in this case. And other things, the auxiliary systems, are the other features or assets which are used to create that particular product which we are using. But still, in the long run, all these different products are part of the same product line, especially if they are managed and developed by the same organization. The game engine itself might not be a that good example, because the game engine is also something that's usually bought by the game studio, and it's a bit of a stretch to say that all the game studios using, for example, Unity are more or less creating a products which are part of the same product line. So basically, the idea is that the product lines take the economic advantage of commonality. So there's only that many changes that you need to do if you are converting from one product to something else that runs on sort of similar domain. For example, if we are transferring something from, for example, the healthcare to veterinary services, it's not of a stretch to idea that, okay, human patients and animal patients might actually be somewhat similar. So our products might be usable also on the veterinary services, whether if we are now working on the Medicare or something similar to that. So the idea is that we only have to do small number of changes around the core assets so we can satisfy the new needs or different requirements of a new market segment. So basically, we explore the commonality and variability to achieve the economy of scope. Like mentioned, the products we develop might actually live for 30, even up to 30 years, because usually the industry or different manufacturing industries, for example, aren't that keen on upgrading their stuff every year or every month or every day. They might do it once in a decade, usually even further apart. So we might want to create something and then create it in a way that we can rewrap the core and make a new product out of it. So that's how we achieve the economy of scope. So of course, the product lines are not useful or shouldn't be even considered if we are doing a single system development. If we are making one-time thing, it's also not just a configuration architecture or versions of a single product or set of technical standards. It's more or less of an idea that we have services or parts which we can reuse somewhere else to make a new product which actually costs less than developing a completely new product. So basically, what the word we are looking for here is a strategic reuse. So product lines means that we strategically reuse our existing parts or existing work to create something new, something novel, or something that gives us more money or more customers or more users or is more useful to a new group of audience. The idea is that, of course, the difference about the reuse in software product lines is, of course, we are talking about the business dimension. We have fewer iterations. We do pre-planning work. We see that our architecture is something that allows us to make similar product or reuse the components in a similar product targeted to some other segment or to some other use. So basically, there's some connection to the product, but the idea is that we are already designing products so that we can use them somewhere else. There's actually one funny example on this from the Sega game consoles. If I remember correctly, the Sega Genesis game console mold, which was used to punch out the plastic cover of the console, was actually reused as a cover of a dental work drill machine or something like that. So if you went to the dentist's office and sat down on a chair waiting for the operation to begin, there might be a Sega Genesis console right next to you, but it was completely white and there was only a drill coming out of it because it was actually cheaper to buy the mold than make a completely new one, and they just bought the mold from the Sega, which discontinued the console, and then drill a couple of new holes in it, and there you have it. That's your industrial. That's the shape of your new dentist's work tools system. But anyway, this is this is not about the physical reuse. This is more about the software reuse, or the idea that we create the architecture in a way that we can do mass tailoring or mass customization for the different users. So basically, the key concept is that we use a core asset or number of core assets and in a product of related set of products, meaning that we take the parts that we already know that work, that are of high quality or good enough quality, and then just add the new parts in software development work, which make a completely new product. Not really that complicated, really. So the idea is that we are doing three things. We develop new core assets, we develop new products out of them, and we manage this process. Of course, the core asset development is the work in which we try to find the new important parts which we might consider useful in all of the products we are making in the future. In a games development context, this could be something like making a better physics engine or adding support for the new graphical cards or graphical chipsets to our game engine. On the other hand, on other products like making a tool or framework for web store, we add support for this new quick chip payment terminals or something like that, which then replicates to our all new products, allowing us to create more new products based on these core assets which define the set of features we have in our core. Of course, this means that these things are, well, more serious development work, because we are creating something that's reusable enough to the degree that when we develop this thing, we might only have the one proof of concept thing available, but we are trying to develop something that functions in the future in several different products, even in things that we haven't even thought of yet when we are doing the development work. So we might have some production plans. Of course, we should have some production plans, because otherwise we wouldn't be doing the development work. But still, it should be understood that we are doing work to create the core asset first, and then wrap these core assets into the products which we are using. So not only is the tailoring done when we are actually doing the product, but it also means that we have to that we are actually looking for the target audience or the requirements or what the things people might actually need in the production phase, not when we are necessarily developing the core library. But this actually means that the product development is when we are combining these core assets and making a new product which tries to use most of them in a way that creates new core assets or gives us a feedback on how things work or what we might actually need in the future, or what sort of things we need to revise or upgrade or maintain. For example, it's completely possible to re-engineer one core asset based on a product which says that this is something that's okay for now, but it could be better. But in any case, the actual sort of normal development work, or the sort of normal software engineering process, which most of you probably are thinking about when you are thinking about software engineering, well, that and boredom. But still, what you probably are thinking about is the product development cycle here, not the core asset development cycle, which was mentioned earlier, because the core assets are developed so that we can have features or we can have products which are done with the production line thinking. The core asset development might start with the situation where we don't actually have anything yet. We just are looking for ways of implementing some feature or idea on our framework, and then the product development comes next. And finally, of course, the management is the one that runs all this work. Unfortunately, in everything, the management is one of the things, but especially in this case, it's important because all the money comes from the product development side. But on the other hand, all the features more or less come from the core asset development side. And if we have too many core assets, this entire thing is completely meaningless, because of course we have the core assets, which are the assets which allow us to do strategic reuse to the degree where we can quickly launch a new product if we need or find or identify somewhere where this thing is useful. So basically, well, if you are doing a production line development, you need to do the core asset development so that you actually have them. You need to do the product development so that you actually have a product which is created based on these core assets. If you are doing product which doesn't use these core assets, you are wasting your time doing the core assets. And on the other hand, if you are doing just core, if everything is a core asset to you, then this is also meaningless, because you are probably wasting time or money or resources in some other way, developing over and over and over again something that could be codified or made a static version and then modified if necessary for a new product. On this aspect, I want to remind you of the example of 3 programmers who created 3 artificial intelligence routines for the software product or to their game product. One for the AI who drives cars, one for the AI which walks the characters, and one for the AI which manages the ships, simply because they didn't know what each of them were doing. In this sense, or in this idealistic example, the AI would be the core asset, and what the AI is doing in each of these iterations would be the product development. If we are making a game where there's some guys walking, or if we have ships, or if we have cars, this sort of thing. And it was the management who dropped the ball when it allowed the three different developers spend a considerable amount of time doing the artificial intelligence 3 times over. So basically, the idea is that the organization manages this work. So they try to oversee the best practices, so try to identify the core modules or the core parts, and provides support for the new projects, or at least define to the new software engineering project that with the technical management work and these sort of things, that okay, we have these parts already and you should combine them and write the code or based on this framework develop something that fulfills these new requirements. Of course, if you consider this another way around, this is more or less what already happens, for example, in many open source development work. We take a framework and start working based on what was given to us and what the framework is able to do, and then just fill the blanks or make the user interface or fill the content so that everything works and we have a product. So, of course, how these different essential activities divide the different things. Well, the framework is here: software engineering, technical management, organizational management. So what sort of things we need to consider when we are doing the software product line thinking. So, of course, software engineering has more or less all the things that you'd consider them to have. Organizational management, including funding and market analysis and operations and these sort of things. The technical management, doing the scoping and decisions on what we actually want to, what data do we need to collect, or what configurations are we using, what parts will be used on existing works. Still, they stay the same. So, of course, these are more. Some of these slides are taken also from the referenced openly available slides. I don't necessarily completely agree with this idea, but still, if we are doing something in a large degree, the software product line development work, or the ideology of doing software product line development, of course, it's going to be necessary. It saves you money if you are already using the components or parts which you know that are actually functional and usable. So in this sense, the product line architecture is central to success is sort of true, because of course, if you are in a state where you can use you can do strategic reuse on a software products, of course, why wouldn't you do that? Would you just rather pay money for people to develop the parts over again and again and again, and do the quality assurance for work, find the bugs, fix things that you know that are already fixed somewhere else? So in this sense, if you are able to combine all these things, by all means, follow this idea. So, of course, these are the things that cost money on a software project. It's architecture, components, test plan, test cases, test data, business analysis, project plans, tools, processes, people, skills, training. Basically, most of the costs, however, are focused on the time the people are taking to develop something. If we are talking about small scale stuff, all of the costs, for example, in a small software developer or studio, is more or less related to the human costs, the salaries, these sort of things. If that's why also many small game studios or app developers have only owners as their employees, because the owners will get paid if the product is successful, and the owners are basically taking a loan against their future success on the development work. But in any case, if we are going from this stage to larger scale, of course we are going to start having problems simply because the information keeps disappearing. And of course, in this sense, using a common architecture or common software components and reducing the amount of test plans and test cases and the required test data, because we are already using parts which we know have been through quality assurance and quality control activities, or parts on which we already know that this configuration works in this business or this area. It all saves money because, of course, it's a redundant work which we can skip because we can rely only on things that we already know. So in a sense, the software product line idea is that the productivity and quality goes up and the relative cost and labor needs and time to market goes down, especially if compared against doing everything again from scratch. Of course, because we already have parts, the core assets, we only need to do the tailoring work, the additional development. So that's less labor needs. We don't have to use people to develop the complicated, difficult core parts because they already exist. We can make everything faster because we already have more or less part of the things available. We know it's of high quality or high-ish quality, adequate quality anyway. And we can also, in a relative sense, get more productivity out of our development work because we have several products with the relative cost of fewer products if we are following the product line based approach. So there's a sort of a payoff point here. That's more or less the idea. There's also a reference to it. So if we are doing everything with the signal of development work, it's of course linear progression because you always have to pay the same amount of money if you are doing development of products from scratch each time. But if you are using product lines, of course, you are going to get the economy of scale or economy of reuse at some point. And that this is the idea why this is also for consider it a favorable approach if we are going into large industry. And this is also something why, for example, in large software houses products, they all sort of resemble each other because they more or less probably share the same components. So in summary, the software product lines epitomize the concept of strategic planned reuse. The product line concept is more about the way to manage the assets than about the technology. There's nothing really about technology or techniques or anything to that sense. It's about strategic asset management, asset reuse. But a bit of similar idea as with the configuration management. Although in the configuration management, we are more focused on one product or one build or one version of the product. Whereas in the product line development work, we are thinking about what could we also do with the core assets that could be released as its own product, or how can we sell our existing work as a part of some new product or use our parts to make something new. So this is basically what the product line activities and practices are. So a couple of final words here. Well, we are running out of time. What you should remember from this lecture are the basic concepts of software configuration management and product lines, obviously. In the exercises, we are testing out, well, doing something small scale about the configuration management, and you are also expected to find out more information about the product lines and product line thinking. So go check those out and submit your works when you have done them. Also, keep in mind that next week will be the exam week. So we will not have a new lecture then, but we will have extended deadline. So you have 2 weeks to complete these assignments, and the next video will be released when the week 8 lecture would have originally been. So on Monday afternoon, you will have a new set of things to listen by me. Finally, well, there will be 3 more theory lectures. Then we will have a visiting lecturer if the visitor who I have been trying to lure here is available, and then we will be having the student seminars. So overall, we are now at the half point of the course. 7 weeks done, 7 weeks left. So good work so far. Try to get your project works done, and remember that even though you are or you might be presenting your seminar work on the second seminar day, you are still expected to submit it before the first seminar day, because based on your submissions, you will be randomly assigned to either the first or the second seminar day, because there's so many of you that we can't do them all on the on one day on a 2-hour slot. But anyway, thank you for listening this time, and have a nice spring break. Thank you.